All right. Problem 5. Let's go. The home stretch. Okay. So here we have... Ooh, that's cool. Okay. We have that market demand is 200 minus 10 root p. So we're just kind of given a demand function. On the supply side, there are 10 identical firms. Each has this cost function, 60 minus 3q cubed. The 60 is an avoidable fixed cost. Finally, we're given that the input costs are W is equal to 4, R is equal to 1. Okay. So this is the setup. I should probably move this down a little bit so it doesn't cut that off. All right. So A, we're asked to find the efficient scale of production. I admit I was thrown off by the input costs because it's not like we have to do cost minimization here. I don't know. Okay. I don't know why those are there. But anyway, the point is, for part A, we want to find the efficient scale of production. So this means we minimize the AAC and this will give us the quantity which minimizes the AAC. That'll be the efficient scale. So here we have C of Q is equal to 60 plus 3q cubed. 60 is an avoidable fixed cost. Okay, so this means the average cost, the average avoidable cost. I'm just going to say average cost. My bad. Avoidable cost. I get those two mixed up. I say average and I mean avoidable, and it's a mess. Okay, so the avoidable cost is just 60 plus 3q cubed. So the average avoidable cost is going to be average cost divided by q. So this is 60 over q plus 3q squared. All right? I just divided the average cost by q. So I want to find AAC min. So what I do is I take the derivative, set it equal to 0. We'll see that a lot. So this is negative 60 over q squared plus 6q. I want this to equal 0. This is the optimality condition. I need this derivative to equal 0 for this to be minimized. So this holds when 6q is equal to 60 over q squared. In other words, I have q squared is equal to 60 over 6. So q squared, not q squared, q cubed is that. So q cubed is 60 over 6. So q cubed is equal to 10. In other words, q is equal to 10 to the 1/3. All right, so this is the efficient scale. Yeah, green. Let's go. This is the efficient scale. Okay. Now, given this, we want to find the supply function of each firm. Then using that, we want to find the aggregate supply function. So we're just going to add up the supply functions for each firm. And we assume that there are 10 firms and there's not going to be any free entry. So we're just fixed at 10 firms. Okay, so one thing that's useful to compute is we found the efficient scale. Now we're just going to find the AAC men. So we're going to plug the efficient scale into the AAC, because this is going to be the point at which the AAC is minimized. So the minimum value of the AAC will occur at the efficient scale. So we get AAC min is equal to AAC of the efficient scale, so 10 to the 1/3. So this is 60 over 10 to the 1/3 plus 3, 10 to the 1/3 squared. So it's 60 over 10, 1/3 plus 3 times 10 to the 1/3. 10 to the 2/3, I guess. Or what we could do is we could do 3 times 10 to the 2/3. This is also able to be written as 60 over 10 to the 1/3 plus 3 times 10 to the 1 over 10 to the 1/3. A lot of this is just algebraic trickery. Not trickery, but algebraic fancy footwork. Okay. So I got a common denominator. This just becomes 60 plus 30 over 10 to the 1/3, which is 90 over 10 to the 1/3. Okay, so this is the average avoidable cost. I could also write this as 9 times 10 over 10 to the 1/3. The algebra never stops. So this is 9 times 10 to the 2/3. Okay, so just to summarize, AAC min is 9 times 10 to the 2/3. After a bit of algebra. Let's try a different color. Let's do pink. So the AAC men will be important. All right, so now we can start with be in earnest. So the supply function of each firm is going to be determined by two things. One, we know that firms only produce when the price that they get is greater than AAC min. This is a sufficient and necessary condition for the firms to want to produce. So this is the shutdown condition. This is another way of expressing the shutdown condition, or the shutdown rule. All right, so this is the first thing that we need for firms to be supplying something. Second, when firms produce, they'll set price equal to marginal cost. So they choose to produce some Q star to set P equal to the marginal cost of producing that quantity. All right, so these are the two facts that we'll use. These are the two rules. This is the quantity rule. All right, so the way that we can do this is we can say, all right, we know firms will only produce when the price is greater than the average avoidable cost, and we found that in this part. So we're half the way. Now we just need to find the quantity that they do produce when price is greater than the average avoidable cost. So when they decide to produce, we just need to solve for what this Q is. All right. So the marginal cost for the firm is the derivative of their cost with respect to Q. So recall that their cost was 60 plus 3Q cubed. Okay, so the derivative of this is going to be 9Q squared. So I'm just taking the derivative of this function. It just becomes 9Q squared. So for P equal to MC of Q, we need P is equal to 9Q squared. So this is going to be true only when Q squared is equal to P over 9. And in other words, if we just take the square root of both sides, we get Q is equal to the square root of P over 9. In other words, Q is equal to root P over 3. Okay, so this is when the firm wants to produce. This is the profit maximizing output. We can put these two together. So we want to find the quantity supplied by an individual firm. So we'll just combine these two facts. They're going to produce 0 when the price is less than their average avoidable cost. Oh, I'll just write what their average avoidable cost was. It was 9 times 10 to the 2/3. Yeah. All right. And they're going to produce Q is equal to root P over 3. When the price is greater than 9 times 10 to the 2/3. Right, because this is the AAC min. This is based on the quantity rule. This gives us the supply function for an individual firm. Okay, so this is the one firm's choice. There are 10 firms. So this means, this is ultimately what we want to find, is the total industry output. We know what each firm is producing. We know there are 10 firms. So the total industry output is 10 is QS. I'm going to put an M to just indicate the market output of P is 10 times QS of P. So this is total. This is the number of firms. And this is the individual firm supply. Okay, so we just multiply whatever we have here by 10. So QSM P is going to be 10 root P over 3 when P is greater than average avoidable cost. 9 times 10, 2/3. 0 when P is less than the average avoidable cost. All right, this is your supply function. All right. So where are we at? Again, this is with aggregate. This is aggregate supply when there are only 10 firms and no free entry. Now we just need to find the market price and the equilibrium quantity sold and produced. Oh, I didn't do our check mark. Need to do our check marks. Found this. All right. So we want the market price and the equilibrium quantity. So we need Q demanded at P star. So we need the demand at the equilibrium price to equal the quantity supplied at the equilibrium price. So again, I'm just using this to refer to the quantity supplied in the entire market. This is just notation that I'm using. Feel free to use whatever you want as long as you're consistent. Okay, so we're just going to solve for P star. That's our goal. We want to solve for some P star. So what we do is we just kind of plug in some P star into both of these and set them equal to each other. So what we have is in the problem, we're given that the quantity demanded is 200 minus 10 root P. And then we derive the supply function for the firms. So we have QD P star is, I forgot. I'm preoccupied. 200 minus 10 root P. Okay. 200 minus 10 root P star. And we have Q supply of M. Let's assume, we're going to need it to be positive. So we're going to have this is equal to 10 root P star over 3. And again, we just need price to be greater than this. So what we need is 200 minus 10 root P equal to 10 root P over 3. Okay, so what can we do here? I'm going to write this. I'm going to move this over here. I'm going to get 10 root P star over 3 plus 10 root P. Multiple different ways we could do this. I'm just going to do 200 is equal to 10 root P star 1/3 plus 1. I'm just showing a lot of steps here. 200 is equal to 10 root P star times 4/3. I just want to be explicit about this. So 200 is equal to, divide by the 10. So I'm just going to divide this 10 right here. So we get 20 is equal to 4/3 root P star. So I'm just going to write this down here. I'm going to multiply this fraction, the 4/3. I'm going to divide by that. So I get 20 times 3/4 is equal to p star. This means that 15 is equal to root p. So p star is just going to be 15 squared. So this is the equilibrium price. That's not what I wanted. It's going to be a nice verdant green. Now, we just need to find the quantity in equilibrium. So, we can just plug this in to the, we can either plug it into the demand function or the supply function. Since these will be equal at the equilibrium price, it's going to be exactly the same answer. I'm just going to plug it in here, just for kicks. Q star is going to be QSM of P star. So it's going to be, it was 10 root P over 3, 10 times root 15 squared over 3. I just want to check. Yep. Okay. So this is going to be 10 times root 15 squared, which is just 15 over 3. This is 150 over 3, which is just 50. Nice even number. Okay. Just to summarize. We found the equilibrium price and quantity in this market. It's important to note that this was under the assumption where there wasn't free entry. All right, this was with 10 firms. So of course we're going to get something different than if there was free entry, and if firms were able to enter until they got zero profits. So if there was free entry, we'd see P star in the long run equal to the AAC min. And that was 9 times 10 to the 2/3. And then Q long run star. So again, this is if this is what we found. This was the answer to the problem. And I'm just saying if there was free entry, what we'd have is price is equal to AAC min. And quantity would be equal to the demand at the AAC min. So it was like 200 minus 10 root P long run star. So it'd be 200 minus 10 times the square root of 9 times 10 to the 2/3. This is 200 minus 10 times 3 times 10 to the 1/3. It actually kind of, I don't know, simplifies a bit nicely. Not really, but I'm gonna just figure out what this is in real time. Sorry if there's a bit of a delay, but I'm curious. Okay, I just plugged that in. Oops. Sorry, my computer's being a tiny bit slow right now. Okay, so it's about like 135. Again, this is just kind of an exercise. This is not what the question's asking. This is just me giving you an extra example of how it would be different if you had a different environment. The answer for this problem, again, because we assume that there are only 10 firms, there's no free entry, is the price is 15 squared, quantity is 50. If there were free entry, we'd see price equal to AUC min and quantity equal to the demand at that price. All right, thank you for watching. Best of luck studying. You got this. And have a nice day. All right, bye.